Hello, this is Kedulytics and welcome to today's session. If you are new to the channel, we encourage you to subscribe to the channel and turn on the post notification bell. So in this video, we are going to look at some of the assumptions behind the t-test, exploring it using the STATA platform. So we are going to explore these assumptions using STATA and see how we can adjust, how we can run these t-tests or comparison of means or medians using this platform. I mentioned mean and median. Why? Because when we realize that our data set is parametric, then we'll need to use the mean or compare the mean. And when we realize that our data set is not parametric, then we'll need to compare the median. So the assumptions that the t-test is based on the normality assumption, 2, equal variance assumption. Now, if these two assumptions have been passed, then you go ahead to run the t-test without any adjustments. However, if any or all of these assumptions are violated, then you have to adjust what statistical tool or that you run. So now let's start. Let's see how we can compare systolic blood pressure between two categories. So let me showcase the category I am interested in. So that's PKI. So there's the tab. So the categories are normal and abnormal. So we want to see how systolic blood pressure varies. What are the mean of systolic blood pressure? Is it high among normal or abnormal? How does it vary? That question, to answer it, we run the t-test. So now we have to check whether our systolic blood pressure is normally distributed. And basically our outcome here tells us that it's normally distributed. So it has passed the normality assumption. How about the equal variance assumption? So we can check that using the SD test. The SD test. So SD, then we click on SBP, which we are interested in. By what category? By what category? Our category of interest is this, right? Yes, then bracket close. Okay, so there's no caps, right? Yes, so the codes are very case sensitive. That is why it's returned that error. So the p-value here tells us that our equal variance assumption has also been passed. So here we have passed the normality assumption and we have passed equal variance assumption. So then we can go ahead and run our t-test SBP by the category of interest. You can equally type it, but then I prefer to select it from the top there in order to avoid making errors in the typing. Right, so it tells this is it. So this is a t-test. So here we have the mean of this and this is higher than that, and it's significant that this difference is actually significant. So this is how you can perform the t-test when you have passed all the two assumptions. Now, assuming that you pass the normality assumption, but you don't pass the equal variance. So assuming that we are not able to pass, assuming that CR, for example, pass normality, but then when we run the equal variance assumption, the p-value is significant, telling us that we did not pass equal variance assumption. What will we do? In order for us to run t-tests where we don't pass the equal variance assumption, we have to adjust our code a little. How? This is it. So you run
t-test, then the variable comes, then by the category of interest, this, then you add an equal Welch. Yeah. So immediately you add an equal Welch, it solves the problem. So this is what you do when you realize that you passed the first assumption, but the second assumption has not been passed. Now, what if the first assumption has not been passed? Usually, when the first assumption is not passed, the second one, you don't even worry your head to do the second one. You just go ahead to use the non-parametric version. It is only when the first assumption of normality is passed, then you go ahead to check the second assumption, which is the equal variance assumption. And where it does not pass, then you add an equal Welch to it. Now, assuming that we run, okay, so let's do SWILK on. Yes, so this tells us that creatinine level is not normally distributed. And because it is not normally distributed, we don't even go ahead to run the equal variance assumption. Because creatinine level here is not normally distributed, we don't even go ahead to check the second assumption. Straight away, we run the non-parametric version of the t-test, which is the rank sum. So you run the rank sum test, rank sum by this category, and you go. So this compares median, not mean. So it compares the median. So these are the three situations that you can encounter when you are running a comparison of a continuous variable between two categories. One, you have to first check to see the assumptions. The first situation, if you pass normality and you pass equal variance assumption, then you go ahead to run the t-test as suggested by this code. Now, the second situation, when you pass normality, but your equal variance assumption has not been passed, in that case, you run this line of code where you add an equal Welch. And finally, if the first assumption, which is normality, is not passed, you don't even worry your head to check the second assumption. You go straight and use the non-parametric version signified by this line of code. I hope you find this video useful. If you like content such as this, we encourage you to like and subscribe to the channel so you can always benefit from the videos that we release subsequently in the future. Till we meet again, say bye.